Okay, so I will start my today another live coding session. So in my today's video, I will solve this question. Subarray sum equals k. Given an array of integers nums and an integer k, and I will return the total number of subarrays whose sum is equal to k. Total number of subarrays whose sum is equal to k. A subarray is a contiguous non-empty sequence of elements within an array. So it says I cannot think that empty array is a subarray. Okay, so let me understand this question first. So in this question, the input should be the integer num and integer k. And I will return the number, which is the total number of subarrays whose sum is equal to k. Good. So I understand the interface. So I will be given something like this and this. Yeah. And I will think of the edge cases quickly. So for example, num is empty or not. Yeah. I wonder if this is allowed. In that case, I cannot take any, subarray. So obviously the return should be 0. I just want to confirm. Yeah, and it can't be. Good. And I wonder what's the number in each element. So this could be positive, negative, or 0, or possible, or only positive. I can see that this can be each of negative, 0, positive. I don't know if this matters or not, but I just wanted to confirm. Okay, good. Aside from that, yeah. And k, also k is the same. It can be negative or 0 or positive. Okay. Good. So now I understand the question. So I will think with this example. For this example, obviously the subarrays whose sum is 3 is this, and also this. But aside from that, none of them meets the condition. Oh, let me add this one here. So I will return 3. Okay. So the brute force approach, obviously what I can do is take every possible array, then calculate the sum, and then check whose sum is equal to k, and in then I will return the total number of counts of subarrays whose sum is equal to k. So the time compressive for this approach is assuming that there are n elements in the nums array, and cubed for the number of combinations of start and end. Then for each subarray, I have to calculate the sum, and I need the linear scan, so it takes overwhelming time. So it should be n cubed. But I can speed up with, suffix some array. Yeah. It can be overwhelming squared because I build the, suffix some array in the linear time, and by pre-computing that, when I try to find the sum of each range, I can do it in the constant time. Yeah. I mean, start until the last index, sum minus start until the 3. Yeah. So I mean, if I want this range, sum, what I can do is this one, x minus 1, is equal to this sum. Yeah. So it can be O of n cubed. Good. And I have a tuition that I can extend this suffix sum array approach to, further optimize this. So let's say I'm thinking of this index and the current sum is say 100 and k is say 50. In that case, I have to reduce 50 from in the suffix as the suffix subarray. So if I keep track of the number of subarrays whose sum is equal to 50, I can find how many subarrays there are, which I can reduce, or I should say I can remove from the suffix of the current whole array. And with that, the remaining sum should be 150 is 50, which is equal to k. So with this approach, I think it takes only the linear time. So yeah, because I have to traverse the last index versus the high index, and I will keep track of suffix sum to suffix length count, like this. So with this, when I'm at index high, I calculate the total sum firstly. Obviously, I have to keep track of the current suffix sum in the loop so that I don't have to calculate the total sum from the beginning after moving the high, pointer. So I will update suffix sum, then calculate. So suffix sum minus k and find the count in the hash map. Which is this. And after that, what I have to do is register current suffix sum to the hash map. Yeah. Okay. And increment total count. And I will return total count in the end. Yep. So in this way, the it takes a constant time, sorry, linear time, because for each high index, all the operations are constant. Yep. This is just the addition, this is just the subtraction, and this is just the this is just fetching from the hash map. Yep. And this is just the incrementation, and this is just the register the hash map, which is going to only the constant time. Okay. So it takes the O of n, linear time complexity, and space should be O of n because I need the hash map here. And let's say each suffix has a different suffix sum, like 1, 2, 3, 4, 5, 6, 7, or maybe 1, 1, 1, 1, 1. In that case, yeah, suffix sum should be up to k there should be k keys, and value is just an integer. Oh, sorry, there are n keys, so that space complexity should be O of n. It can be reduced. I mean, number of keys get smaller. Say let's have 1 minus 1, 1 minus 1, minus 1. In that case, the suffix sum could be 1 or 0. So number of keys should be smaller. Yes, less. But in the worst case, there should be n keys. Okay, good. So let me start the implementation with that. And calculate. So this is the remaining suffix sum, or I should say suffix sum to be deleted. So oh, and as I said, I need the suffix sum count. So after calculating this, I will take a look at this. I think this can be just used here. So this is the number we count when the high index, for this high index, as a found count. Update it and register. So this, and I return the total count. Okay, good. So this is, I mean, I've just done what I've written, sorted out in line 28 to 34. Good. Yep. Okay, so let me just work through my code. So in this case, there should be 1, 2, and 3 subarrays whose sum is 0. So I do this. Again, 1, 2, 3. Good. Okay, so I start with current suffix sum 0. Suffix sum counter is empty and total count is 0. Okay, so for high, I move from index 0 until index 2. And I start with index 0. When high is 0, nums high is now 1. So current suffix sum is now 1. And found count is suffix sum counter. And key is current suffix sum 1. Wait a minute. Current suffix. Yeah, this is correct. Current suffix sum is 1. And k is 0. So this should be 1. But there's no 1 key yet. it is counted as 0. So find the counting of 0. So now total count is plus 0. So now in line 61, current suffix sum is 1. So now suffix sum count should be 1, 1. So this key one is, the count of this key one is incremented by 1. Good. And I go back to line 55, and now I'm at index I is 1. So nums high is -1. So current suffix sum becomes 0. Yeah. Oh, seems like I forgot some edge case. So good. With this suffix sum counter, I have to register this first. This suggests that the total current suffix sum is equal to k at specific index. In that case, the whole array should be buried. Yeah. So in that case, I can think that the removed suffix array is an empty array. I have to count that empty array into the counter. So that's what I did here. Yeah, I forgot to see one edge case. Okay. So good. Where is it? So high is now 1 and nums high. So current suffix sum becomes 0, and 0 minus 0 is 0. So suffix sum counter has key 0 as 1. So found count is now 1. So total count is incremented by 1. Yep. And then now suffix sum counter, current suffix sum, which is 0, should be incremented. Good, so far good. Now I will take a look at high, index 2. And now high is 2, so nums high is now 0, so current suffix sum is now 0. Yep. And found count is, because current suffix sum is 0k0, so it should be key 0 in suffix sum counter, and the value is 2, so found count is 2. So total count is incremented by 2. And I register something into suffix sum counter, so this becomes now 3, but it doesn't matter. Okay, then I finish the iteration and return the total count 3. Good. So I confirm that this test case passed. Great. And I covered all the lines in my implementation with this dry run. I'm pretty confident on my code. Yeah, it's good that I could find one edge case. Not the edge case, but basic thing I have to cover. Yeah. Okay, I submit my code. Great, accepted. Okay, now I finished my today's coding practice, so I quickly wrap up. So today I said the question, Subarray sum equals to k. So in this question, I'm giving an array of integer nums and integer k, and my task was to find the total number of subarray whose sum is equal to k. Yeah. And so as my solution, my first solution was the brute force approach and cube solution, but I could optimize that into n squared with the suffix sum array. And I extended this idea, and with using the current suffix sum array, I basically use the suffix sum counter, which is a hash map. And with that, I could solve this question in the linear time complexity. Okay, so I finished my today's coding practice. Thank you so much. Bye.